is the reaction. So iron hexyalkyl plus 3. So that is referring to the iron charge. Of course, it's the diocyanide. So equilibrium 4. So this one still is plus 3 because this one is minus 1. So, but the overall, of course, plus 2. So the valence state for the iron is still plus 3. But anyway, so this one is color plus. This one is red. So therefore we want to find the molar extinction coefficient of this one. And then we want to find the KEQ. And then we want to do the delta H and delta S of the reaction. So, just very quick, how we find the molar extinction coefficient. So, if we know the concentration of this one, so we have different concentration, and then we have the absorbance. So we make the plot, and the slope will be the molar extinction coefficient. And then the KEQ, of course, we have the only one product and 2 reactants. Now, keep in mind when we say KEQ, all the concentration should be equilibrium concentration. So this one would be iron. And this one is iron. This one is. So keep in mind is equilibrium condition concentration. When we observe the data, we observe the absorbance, so we can find the concentration. Remember from the Beer's law. So absorbance, and then equal to E, B, C. So B is 1 cm. So E is the constant. So if we know the absorbance, we can know the concentration. So whatever the concentration there is learned from the absorbance. But equilibrium is different than the initial. All right. Keep going. So with this in mind, all right, so let's take a look at our worksheet.
Wait, is that
Yes.
an H under the FE plus 3 and SCN? At the bottom? Bottom. No. Like where it says in? What's that?
In means initial.
But that.
Not equivalent.
So
Equilibrium.
not equal
Not
to,
equivalent.
Not equal to.
not the same. Initial and equilibrium, they are not the same. So do not confuse with initial and equilibrium.
Oh, okay.
Are we good? So that's what we've been, I'm sure in the lecture, we've been talking ice table. I for initial, C for something change or, become less or more. E is equilibrium. So I and E are two different things. Yeah? Okay, so keep that in mind. Okay, so one more time, go to the island, yes, and take a look at the what we have for the lab schedule, which your lab report will due next Wednesday. And take a look at the syllabus and see what we would need to have the lab report, all right? So, and then we go to the worksheet, all right? So, number 5. So that will be a blank worksheet. So this is your empty or blank worksheet. So again, I would say get to computer or what. So you work on this one while you have a cheat sheet. The cheat sheet is in the notes. And the cheat sheet is this one, and of course I will work on this one, and I may not save and upload our latest one, but this is just again as an example anyway. Now before just mechanics, all right, some logistics, make sure you type all the info in here, name and blah blah blah, on each page. We have a multiple page worksheet, and so I want you fill in the blank each page. If one page is missing, I get upset. I will take 2 points off. And you will get upset too. So let's not do that, all right? And fix, so when you type in something and then you move, fix it, don't just turn in, I know. And same thing for the WAV. All right, so some of you don't know how to do the WAV. When you print out, it look funny. Learn how to do that, although we are not a Excel class. Okay, let's work it out together then. Task 1. What wavelength you were looking at? Anyone donate your data?
457.
456?
7.
457? Make sure you have the unit, all right? So the unit is already in the cheat sheet, but somehow again, I don't know why and what, student delete the unit and then hit print. It's just ouch, okay? So don't delete already answers there. I gave you answers, all right? So it should be nanometer. So there's lowercase too, by the way. We come back to the epsilon in a minute, all right? Let's take a look at it. So remember we have 5 solutions for task 1, and we can say 1, 2, 3, 4, 5. Number, what can I say? And further, really, number 1, we could do a little description. We call it blank. Now, what do you mean by blank?
One that was just the empty letter.
That means you don't have any, well, look at the reaction. We have the iron and KCl, yes? So blank sounds like one of the 2 or both are missing. That would be blank. That means you don't have it, right? So of course, in our case, it was the thiocyanide was missing because the thiocyanide was not there, so we have the molecule by itself, but we still have the iron. Yeah. Why we still have the iron? Remember the iron, it was tiny bit color. Although I say it colorless. Ideally it would be colorless, but iron is always easily oxidized, especially iron 3, so it would be tiny yellow color. So that will be your little background. We want to test the background. So the blank is without the thiocyanide. Yeah? Okay, because I know we will use this kind of language in the test or the quiz or final exam. One time students say, I don't know what you mean by blank. I say, oh my God. Do we know what we mean by blank now? Okay. Iron. What's the concentration of our iron? So you can take a look at our task 1. What was the concentration? 0.2? Yes. It was 0.2. But what did we do? We used 5 ml of our 0.2 and then 5 ml of the molecule. You add together. And you have a reaction, yes? So 5 ml and 5 ml, now you have how much? 10 ml. Are you 0.2? No. It would be what? Cut half. Why cut half? Because it's from 5 ml to 10 ml is double the volume. So I label this column, A, B, C, D, E, similar to the Excel system. So I call this column D, all right? So what do we do? So we use the absorbance, divide by 5,000, or your slope of the graph. If your slope of the graph is between 4 to 8,000, then use your own slope. If your slope of the graph is something outside, then use 5,000 as a given. So don't use some bad number while we knew the answer. So okay, just like we knew the property is 10. So you use that and get this number. Now, strictly speaking, the equilibrium for our blank should be 0. Why? Because your thiocyanide is not there. How can you make your product? You see what I mean? You don't even put the egg. How can you have egg sandwich? You can have a sandwich, but not with egg. See what I mean? So this one should be 0. But you can calculate because you still have some numbers. But we won't use it, all right? We will not use this piece of data. Each time I say don't use it, you have a number in here, fine. But don't use it for further, yes.
So like when calculating the equilibrium concentration for like SCN, for example, so like if you're doing C minus D, then you do, like the first one you have like 0 minus a positive number, so it'd be negative. Are you supposed to do like absolute value?
Okay, we go into that. So how we calculate the equilibrium concentration of the ion? So it would be B is this number. So yes, really in this example, it would be 1 times 10 to minus third, yeah? Because 2 times 10 to minus third divided by 2, that is 1. Subtract D. D is this number. So this number subtract this number. What if this number is bigger than 1 times 10 to minus third? Then you get a negative number. We will still write it as negative. But by the time you go to equilibrium constant calculation, you will have a negative number, which is no meaning. You know is something wrong. We know is something wrong. How can you make more product than what you begin with? I send out 2 letters to you, but you receive 3 from me. That is something wrong. But you say, yeah, I do receive 3. So there's something going on there. Not supposed to, but sometimes that happens. Why? That could be due to the background impurity that interfere our observation. That could be the instrument error. That could be your solution is not clean. Iron is everywhere. KSEN is everywhere. So that is possible because you only send out 2 letters, but how come you receive 3? You see. But both are true. Then how to explain that? That is, someone using my name to send you letter. Can that be possible? Yeah, nowadays, all the time, So that is what's going on, the impurities. Are we good? All right, so that explains it already the following, all right? So, guys, now, these are the absorbance, okay, everyone? These are the absorbance of your each solution. Now, if when you do task 2, you got a light color, that means it's very low absorbance reading, and that low absorbance reading divided by 5,000 will give you a small number. And if this is a small number, and B is pretty small, 1 times 10 to minus third, that is pretty small. And hope, subtract your D is smaller than B, then you are in business. Now if D is greater than B, then you get a negative number. And that means your KEQ will be negative because KEQ is D, this number divided by E times F. So if your E or F is a negative number, so this will be negative number. And don't change sign. Don't change sign. If you get a negative number, report it honestly and just write down negative. Don't change. Don't change to fool me or fool yourself. Leave it alone. Instead, what do? We would ignore or skip that negative number. We know it's something wrong. But don't change sign. Is that okay? All right. So leave it alone. And so in here we say average of the 4. And we, again, good news, we know the answer. That should be 200 or greater. So if you get 300, 400, 500, 1,000, that's good. On the other hand, if you get 50, that's okay too, not too bad. Any units for KEQ? No units. And this is room temp, so I don't know, our room temp usually is 20 degrees C, so that would be 293 if that's the case. But don't write it like that, okay? But I just spell it for you, that's all. Alright, so if we are not doing method B, then we can skip or just strike out. Okay, task 3. So task 3, we would repeat or reproduce one of the data point from task 1. So therefore, the iron was 0.1, remember? Y is 0.1, 0.2 divided by 2. And then I've been using 2 times 10 to the minus 4, for example. That one would give you about 0.5 absorbance reading, but then it's not 2 times 10 to the minus 4, it would be divided by 2. And then we did 3 temperatures, so that was years ago. One time I don't know why I went up higher. So we have 4 temperatures. So 10 degrees C, 30 and 40 degrees C bar. What about the 20? Where that come from? Room temp. So that will be from task 1. So task 1 in my example here is 0.66. You see? So I copy that 0.66 down in here.